to finally to section 5.3. So we're going to look at the basic definition of the binomial distribution along with the notation. And we are going to be able to get that whole table on our calculator, and this binomial distribution, we're only going to be dealing with situations that have two outcomes: acceptable, defective, survived, died, yes, no, success, failure. So there's only two outcomes, binomial. The last was probability distribution, right? This is binomial, bi meaning two possible outcomes, okay? So again, just like before with the probability distribution, we have four things that are a requirement for it to be considered a binomial distribution, and those four things are: it has a fixed number of trials. That means I'm going to roll that die 5 times, a fixed number of trials. Okay? The trials must be independent. If I roll a die 5 different times, is that independent? Does one depend on the other roll? No, it would be independent. So they have to be independent. The outcome has to be in two categories. Now, if I roll a die, there's 6 numbers on there, but I could change it to say even numbers or odd numbers, right? And if it's even number or odd number, there's 2 outcomes. So that would meet that requirement. The probability of the success remains the same in all trials. The probability of the success remains the same in all trials. So on that die, there are 6 sides, there are 3 even numbers and 3 odd numbers. The probability would be the same for each outcome. Okay, the last section with probability distributions, we had different probabilities for that events. For having 1 girl or 2 girls or 3 girls, there were different probabilities. These have all the same probability. Okay? Binomial, 2 outcomes. So here's some notation. We use S and F a lot, or P and Q. 2 possible categories of outcomes. The thing that it is this is the probability of success. Well, the opposite, Q, becomes the probability of failure. So in the die, one would be the evens and one would be the odds. Okay? Here's the key, because sometimes they're not going to give you both, are they? They just might say the probability of something happened is 47%. Well, the probability of failure would then be 57%, because all I'm going to do is take 1 minus the probability of success, and that's going to equal my probability of failure. Okay? So, as you already know, N is the number of trials, and these are the things that you're going to pick out from the problem to be able to do the problems. The number of trials, N. X can be any whole number between 0 and N, the number of total trials. So how many times would I get an even number in 5 throws? Okay, that would be a similar thing. So it doesn't have to, if there's N trials, if there's 5, how many times will I succeed 3 of the 5? That's what that means. Probability of success in 1 of the trials, and the probability of failure. Or if I said if even numbers, but I got odd numbers. And of course, P of X is the probability of getting exactly X successes in those N trials, in those number of trials. Be sure that X and P refer to the same category called success. In other words, you don't want to mix the probability of giving an odd with the success being given an even. You want to make sure that they're all the same. Here's another one with sampling without replacement. Consider events to be independent if n is less than 5% of the total number of a population. Okay, so here's an example. When an adult is randomly selected, there is an 85% probability or 0.85 probability that this person knows what Twitter is. Suppose we want to find the probability that exactly 3 of 5 randomly selected adults know of Twitter. Does this procedure result in a binomial distribution? The answer, of course, is yes. Why? Because the number of trials, how many people am I picking? I'm picking total of 5, right? And I'm asking if 3 of those 5 will know what Twitter is. Okay? There are 2 possible outcomes, yes or no. They're not going to be allowed to say, I don't know. It's either yes you do or no you don't. Okay? And we do know the constant for the probability, 85% of the population know what Twitter is. So my success is 0.85. My Q for failure would be 1 minus 0.85, which would be 0.15.
I have a question.
Mm-hmm.
Can you confirm, does this procedure result in a binomial distribution? You said yes to that?
Mm-hmm. Okay, what are the requirements?
Oh,
Those 4?
Oh.
Do you want to go back and look? They will have a fixed number of trials. Am I saying how many times I'm going to check, pull people out? 5, right? And are the trials independent? Because selecting one doesn't have any bearings on selecting another one, okay? Third one, does it have 2 possible outcomes? Yes or no? 2 possible outcomes. The probability of success is the same in each time I pick. Each time it's going to be for success, 0.85, failure, 0.15. So we're going to have I just want to let you know the different methods of finding probabilities. There are several. We're going to concentrate, obviously, here in class on using your TI calculator. But we could do it all by hand using the formula. That's method 1. I know all of you want to do that. But n here, n factorial is the number of trials, right? We already know that. N is the number of trials minus x, the number of outcomes that I want to be successful. And the Twitter thing would be 3. So it would be 5 minus 3 to get 2 factorial. X again is 3 factorial. P is the probability of success. And the Twitter example was 0.85 raised to the x. How many do I want? 3 times Q. Q is the failure rate. 0.15 raised to the number of failures we would want, 2. So that formula makes sense. You have to remember which of those is which, regardless if you're using the formula or if you would use another method. Absolutely, absolutely. So we could use Excel. I don't know that I have an Excel one on this. Maybe I should rewrite one and make an Excel one on this. You could use StatDisk, anything like that. I'm sure that's on StatCrunch as well. And the TI 84 calculator, and that's what that would look like. Or you could use a table in the back of your book and appendices. So lots of different methods. So it's going through here and saying that they prefer using the computer software. We're not. We're going to use this. Okay? You can always go ahead and do it otherwise, but here we go. So, on our calculator, we want the probability that 3 come out. So on your calculator, this time we're going to go to a distribution. So again, I'll go slow so we're going to write down our keystrokes because this is a new one you've not seen before. Write them down and then stay with me. I'll give you plenty of time. Second, and we're going to click on distribution, which is over the button that says VARS. Okay. Once you see this screen, you're going to use your down cursor key and you're going to cursor all the way down till it says, and it's letter A on your calculator, binomial distribution. Does everybody see that one on their calculator screen? Cursor down to binomial. It won't let you go down anymore?
Is it only past 7?
Oh, you're on VARS.
Oh.
You didn't get your second in. Second distribution. There you go. Okay. Second distribution. Okay, then cursor down to where it says binomial. And we're going to choose that one. So I'm going to press enter. Those of you with a TI-83, you're in the same situation you were before. It's saying binomial, and does it have a parenthesis that opens? Okay. You're going to put these in the exact same way, in the exact same order. The first thing you're going to put in is N. N is the number of trials. In our Twitter example, we're selecting 5 people. So my N is 5. Those people with an 83, you're now going to type a comma. No, I'm putting in the number 5. And then you'll put in a comma. Okay? I'm going to cursor down now on my 84. And it says P. It doesn't say Q, it says P. That means the probability of success. My probability of success is 0.85. So I'm going to type in 0.85. Those of you with an 83, after you put that comma, you're going to put 0.85. Then you're going to do another comma. Pretty cool? My X value, I'm going to cursor down again. How many successes did we want? Exactly 3 of those 5 people, so I'm going to type in a 3. Those of you with an 83 are going to type in that same 3. I'm going to cursor down, and I'm going to hit paste. Those of you with the 83 are going to close your parenthesis so that now your screen looks exactly like my screen. Once you're there, you press enter, and the probability of 3 is 0.138178125, and obviously I would round that.
Also, you never do anything with the Q. The Q is
Not no, because I'm doing it on my calculator. Okay. I could, if I pumped it out by that formula, I would have to put Q in. Oh, you went to the different one.
Oh.
Second distribution, and it's A. It's letter A.
Yeah, that's what it said. Oh,
Oh, it's 0 on yours. I'm sorry. See, on mine it was A.
oh mine was.
See, yours is, I know, see, and I don't know all of them. All the screens, I just don't know them. I try to keep up, but. So yours is going to be on 0 and not A, okay? For your operating system.
PINOM, PDF, and then PIN.
It's PDF.
PDF.
It's PDF, yes, correct. Okay? Everybody cool now? So that's not too bad.
And what does this tell us again?
This tells us the probability of selecting 5 people and asking them, do you know what Twitter is? And exactly 3 say yes. Okay? All right, so here's the formula. We go back in, number of outcomes. It just tries to make sense of what the formula needs. And of course, we already talked about P being the success, Q being the failure. So here we go. Here's some examples. You know we were coming to those real soon. Using the probability, we're not going to use the table. What are we going to use? We're going to use the TI-80, 384. Assume the random guesses are made for 5 multiple choice questions on the ACT tests so that there are N is equal to 5 trials, each with a probability of success, meaning they are correct. Well, if I got 1 in 5, the probability would be 20% or 0.2, so that's my probability of success. Use the probability, well, we're going to do the calculation on our calculator. And number 15 says find the probability that the number X of correct answers is exactly 3. So I'm going to go to my calculator. We'll go through this one. Oh, I better go through the other one too. Again, same thing. We're going to go to second, distribution. We're going to cursor down to binomial probability distribution. Hit enter. My trials is 5, good. My success rate probability is 0.2. And the number of things that I want correct are 3 problems, exactly 3 problems. So 3, and then I'm going to put paste, and those of you with an 83 should have the same thing across your screen now. And hit enter, and I've got a probability of 0.0512. Is that unusual? No, it's usual because it's greater than 0.05. Very good. Okay. So, if you recall from last section, when I have number 16, find the probability that the number of X correct answers is at least 3. I could have 3 correct. I could have 4 correct. I could have 5 correct. And so I could do this entire calculation for 3 correct, 4 correct, 5 correct, and add them all together, right? In the last section, it gave us the whole entire table, didn't it? So we could just get the numbers we need. Well, you can do that on your calculator as well. So let me show you how to do that on your calculator. Again, we're going to go to the same place, second, and distribution. Cursor down again to binomial probability distribution there, and A. We're still doing 5 trials, right? The success for outcome is still 0.2. But I don't want to know just the value of 3. I want to know all the values. So I'm just going to delete that and leave that blank. Those of you on the 83, so now you'll have punched in second, distribution, binomial probability distribution, then parenthesis, you'll have your 5, comma, 0.2, and you're going to type in your ending parenthesis. Okay? On the 84, I'm just going to come down to paste and hit enter and stop right there. Don't hit enter again, okay? Because I want to look at it. I want to see everything. If I just hit enter now, it's going to give me this thing that goes off my screen. So I just want to look at it easier. So what I'm going to do is come down here to the store button. So come down to the store button. Wow, we're going to be out of time. So I'm going to say store, and I'm going to type in L2. And to type in L2, I'm going to do the second key and the number 2 key. And you see that little arrow on your screen that says store to L2. That's what you should see. Okay? When I press enter, I'm going to have that whole thing give me a cross what those probabilities are. But if I go into my list, everybody go to your stat. And edit. Well, L2 now has all of those probabilities. It stored it there for you. So you have to fill in, though, L1. You have to fill in L1. So what are my possibilities as I get 0 correct? So that should be the first one. 1 correct, 2 correct, 3 correct, 4 correct, 5 correct. There were 5 trials. So all I did in L1 was put 0 all through 5. And now I have my entire probability distribution, which in 5.2 it was kind, it just gave it to us, right? So now there it is. So it makes it a lot easier now to answer 16, find the probability the number of X of correct guesses is at least 3. What am I going to do? I'm going to add the probability for 3, the probability for 4, and the probability for 5. Okay? Hmm? I'm sorry? How do we get the arrow?
No, the values in L2.
And L2, those are the ones we said from our probability distribution, and we said store to L2. You have to hit that store button to L2.
I think stored to L1, that's why.
That's why. See, you scored it to L1 instead of to L2. You store it in L2, and then L1, you're going to put your 0 to however many numbers of trials. Store it to L2 and put in the numbers in L1. You're good. So you want to put store. And you're going to say second, number 2 is L2. So now you've stored it there and press enter. Then go to stat, edit your lists. There everything is, and you just put 0, 1, 2, 3, 4, 5. Okay? Okay?
Something here first. I don't know.
Oh, you already had something in there. Oh, you put it down here. That's why you pasted it down there. Okay. So I'm going to go up. You pasted it right in here. Okay, so I'm going to second quit. Okay, let's see if we got it there. Okay? All right, so that's how you're going to answer all the questions in 5.3. I do have ones for you to practice. I hope I would have had time for you to practice together in a group, but I didn't. So when we come back together on Monday, we will do those practice problems as well. Okay?